Okay, again, as with all of the proofs, what we're going to do to start with is copy down our given information. So what we are told here is that TQ is perpendicular to PR and that PQ is equal to RQ. Okay, so as always, you're going to begin with your givens, which means if you have 4 proofs, how many points should you guarantee to have on your final? Very minimum. 4, right? Because what's the first reason always going to be? If anybody misses that, and I've had one person miss it in the last like 4 years, they just were careless. So make sure that you get that. That's 4 easy points for you. Okay, but when you look at this proof here, okay, again, any approach to a proof, you look at your final end state, what it's asking you to prove, and you want to see what are the different ways that you can make those statements. Okay, so in this particular case, you have angles 5 and 6 that are equal. There's a couple different ways that you can eventually prove that. One, if you could prove that TR and TP were equal, that makes it an isosceles triangle. And you know, in an isosceles triangle, the base angles are equal. So if we could show that TR and TP were equal, we'd be able to show angle 5 and 6 were congruent. Another way, though, if you look at this, we have these 2 triangles that look congruent. Well, if we could prove that the 2 triangles are congruent, therefore their corresponding parts are congruent, again, we could show that those angles are equal. Okay, so you're going to use one of those 2 ways. See if you can build up to that relationship. Okay, so since there's no really direct line that you're not really sure which of those methods you might be using for this proof, you may want to start out by interpreting your given information. Okay, so if we know that PQ and RQ are equal, we do have 2 parts of that triangle, which is helpful to see. Okay? And we also are told that TQ is perpendicular to PR. Well, what does that mean? If things are perpendicular, it means what? It's a right angle. So we could say that angle 1 and angle 2 are right angles. And that's definition of perpendicular. Okay, so by that definition, we know they are right angles. Therefore, if 2 things are right angles, what are they with respect to each other? Equal. So the measure of angle 1 is equal to the measure of angle 2. This is one of the postulates we started with, which is all right angles are equal. Okay, so based on that relationship, okay, you know that you have these angles as being equal as well. All right, so now in looking at that, we do have 2 corresponding pieces of congruent elements. In the patterns that we've dealt with, we need 3. It needs to fit one of the patterns, SSS, SAS, ASA, or AAS. Well, we have an angle and a side, so if we could either find either of the other angles, or if we could find this side that gives us the pattern SAS, we can show congruence of triangles. Do we have either of those? Yeah, TQ is equal to itself. So TQ is equal to TQ gives us that 3rd piece, this side. And the reason for that is something is equal to itself is called reflexive property. So by reflexive property, we have that information. And now if you look at this, we have a side here, we have a pair of angles here, and we were given a set of sides. And the fact that it falls in the pattern of SAS in our proof is a coincidence, because step 4 could have come up at step 2. But when you look on here, we see our pattern, 2 sides and the angle between the sides. So we can now show that triangles PQT is congruent to, and what triangle would that correspond to? RQT. And the reason is the pattern here, 2 sides and the included angle, SAS. And finally, our last step then would be to show that these corresponding pieces, angle P and angle R, P and R do coincide. So we know that measure of angle 5 does equal measure of angle 6. And the reason is what? CP, CTC, corresponding parts of congruent triangles are congruent, or we could also call it definition of congruence. Okay, so either of those will work. Right, just So this is your complete proof. Let me show you an alternate step 2 and 3 though, because you may see it differently or you may choose to use one differently, and that is the definition of perpendicular can be interpreted one of two ways. You can interpret it in the relationship form, which we did here. The angles are right angles. Since all right angles are equal, we can set their measures equal. But you might also interpret it in the measurement form. And in the measurement form, if two things are perpendicular, what do their measures equal? 90 degrees, right? So we could say that angle 1 equals 90 degrees, angle 2 equals 90 degrees. We would still use the same reason, definition of perpendicular. However, our third step would have a different justification if we chose this pattern. And that's because here, if we have two things that are equal to the same thing, therefore they're equal to each other. So again, we have the same step, the statement 3, but our reason, what justifies two things equal to the same thing are equal to each other? Transitive property. Okay, so transitive property or substitution would be your justification there. So these steps 2 and 3 could also have been used in this proof.